Hi there and welcome back to part 7. We have something that almost looks like a game. We have the ability to control the car, admittedly really badly right now, and we have a track. So we're going to do some unfortunate things. We're actually going to do some maths to try and sort this car behaviour out. The biggest issue that I feel is that the car accelerates forever and it gets too fast. So we're going to take a look at that car script. So we have the car script attached to the car. Right now I've still got the camera attached to the car, so it's like a first person at the end of the last video, but we can experiment with a couple of different methods there. Basically we need to try and do some maths to work out how we can get this car script to work slightly better. We currently have a maximum steer amount, a maximum torque amount. What I'm going to add in here is I'm going to add another public, and I'm going to add in, this time it's going to be a maximum speed. What we're going to do in theory is we're going to limit the speed, let's say it's 20, by applying a mathematical formula to how much torque can be produced at different speeds. So in order for that to happen, we're going to have a way of calculating what the speed is for the car. And there's a few ways to do it. One simple-ish way is if you look at any of the wheel colliders, you can actually get the RPM, so the revolutions per minute for this particular wheel, and rather than have to transform vectors and stuff, I think this is probably one of our best bets. So we'll try this and we'll see how it goes. So this is going to be quite maths and programming heavy, and it will hopefully refactor and tidy it as well. So we did camera control, and we did kind of there and here. Alright, so what we're going to do is, you've maybe heard of this Desmos, is a online maths calculator, a graphic calculator. What this allows you to do is allows you to create curves and work out how things are going to work, and I use this a fair amount when you're doing things like this. So there is a different way of doing it involving not having this, but I think this is a good lesson. So the old equation from when I was at high school, y equals mx plus c for a line. If I add a slider for m and a slider for c, you'll see you get this line. So y equals mx plus c is the y value, so the amount up the way or down the way, is equal to the gradient times x, which is the amount along, plus c. And if you drag these around, you see that what happens is if I drag c up to 3 or whatever, then the line crosses at 3. If I change m from 1 to -1, you'll see that the line goes down. And what I effectively want is a line that goes from that gives you the 0 for the x, it gives you the maximum amount of torque. So the m we calculate by probably, if we have let's have a look at our code. If we have a max torque on the y, so it's the change in y divided by the change in x, so the maximum speed. So if a max speed is 20, so that would be in the maximum RPM. I'm actually going to change that now, so max RPM. If I change that to maybe, I don't know, 50, we're going to use these two variables to calculate that, so it'll be max torque divided by max RPM, so that would be 200 divided by 50. So if I put that in, so it would be 200 divided by 50, and because it's going down the way, it's minus 200 divided by 50 times x plus c. So close that. So c for us will be the max torque, which is 200. So if I zoom out here, what we see from the curve is that if we've got max torque, at 0 speed we'll get maximum torque, at half speed we'll get half of the maximum torque, and at 50, which was that our top number? Did I say 50 RPM? Yep. So if I say at 50 RPM, then we'll get 0 torque applied when we try to accelerate. So yeah, that kind of looks like it should work. So I think I kind of explained that. Now let's put it into practice. So what we want to do is we're just going to create a little space in our code here before we apply the motor torque. So we're just going to create a new float. We'll call this actual torque, and we'll make this equal to the minus the max torque divided by max RPM. That's the m part. So y equals m, so if I surround this in brackets, times x times x is the actual speed, so I need to get the back left dot RPM, so that's the actual RPM, plus the max torque again. And I'm having to think pretty hard as I do this. So this actual torque takes into account the RPM of the back left wheel and calculates it by mx plus c. So what we should be able to do is, to the back left, we're going to apply the y input times the actual torque. So that's the torque based on the speed. Now it's only one line, so this probably should be a function, but as I said, it's just one line and this is our first go at coding it. So I'll say I've created the float actual torque here, but I'll use it again just here, and this time we'll use it as back right RPM. So this will apply to the back right. So as I said, it could be a function, but it should be right. So Control S, save that one now. Go back to here. We've got the maximum steer, maximum torque. As this compiles, we should pop up with the maximum RPM, and we've said 50, so maximum torque is 200, maximum RPM is 50, so in theory this should not go faster than a 50 RPM. So it's dragging off to one side for some weird reason, and I'm just going to stop this and have a little look at my code. And yep, ended up being pretty obvious, so I hadn't changed the actual torque here. Actual torque. And I'm just going to quickly change the camera back. I suppose I could show you. So we're taking the main camera right here. The main camera was there. I'm going to take that main camera out. I'm going to, should maybe unplay that. Yeah, so the main camera, I'm going to drop him out again, and I'm going to use that trick where I align the main camera to the view, so I'm sort of in the position that I want. Click on main camera, click on game object and align it with view, and then we'll add on the position constraint component. Choose the race car as the source, and then activate it, and then that way we'll see what's happening. So from this angle we should see that the car, the RPM of 50 is incredibly slow, but because we were clever in how we wrote our code, we made it public so we can change it. So maybe if I do 10 times that, then it shouldn't make any difference. It should just still use those in the calculation. So yeah, it's definitely a lot slower, but you can see that the code that we wrote kind of works and definitely makes the car a lot more stable. I think it's probably a good idea if we tweak those values, and it's been a long video, so I'm going to stop it there. I hope I haven't fried your brain too much with all the maths in it. If there's any requests, if you want to see a different way of doing it using an animation curve where you have a bit more control over how much torque gets produced, then at any point in speed, then let me know. I think we definitely need to at least double this. I'm going to triple it to 1500, and yeah, I'll let you tweak those values, and I'll have a little play with it and see what you come up with. And yeah, I'll see you in the next video. We're going to try and make this into a bit more of a game.